Okay, so thank you everybody for joining us today. So I'll go off camera so that way you're able to focus on that and kind of save my battery because the power is out here in my estate today. Now, just coming back home. Okay, so thank you everybody for joining. So today is our first session for the geocomputation with our study group. So today we're going to be looking briefly at okay, let me just knit this or render the Quarto document. Okay, so I believe you can see my screen. I'm on the browser now. Okay, yeah, thank you. Okay, so the book we're going to be using is okay, let's go back there. We'll open this in a new tab. So Narendra has shared the book on the chat, so you can just click on that link and follow along with me. But I have a presentation, kind of a document that we're going to be using. So I'll be going in and out of the Quarto document to RStudio. So I'll try my best to explain as much as I can, then we can read up on the areas that we can't really touch today. So this is the book. So the book is created by Robin Lovelace, Yakub, and James. So we're going to use this book throughout the session, and the session is just going to be once in a month because of the 4 groups that we're having is going to be two. Some people are actually in the 4 study groups. So we don't want it to be too overwhelming for those who are participating and also those who are facilitating the groups. So that's why, but we don't know what might come up in the future. As we move along, we might try to make it more than once in a month. It all depends. It depends on your feedback and your support as well. So this is the book. So what I would want to advise is that you go through the introduction. I'm not going to go to that. It's a lot of talking there about what geocomputation is, why use R. There's also a version of this book in Python, but from the author's perspective, this is the most comprehensive of the two because of some kind of points that they pointed out here. It's not that you can't get so much from it, but we're looking at R here. Then the authors also compared to the GUI interfaces that we have for geocomputation, like QGIS and so on and so forth. So if you have, I think you should create time to go through the introduction so that we can save time and go into some practical aspects of geocomputation. So they talked about what geocomputation is. So it's the application and development of computational methods for geographic data processing, analysis, modeling, and visualization with command line tools and scripts. So it's focused on performance, reproducibility, and modularity. That's why we are using the command line tools and scripts. So it's not that you can achieve so much with the application of softwares that are like QGIS, but the flexibility lies with using the command line tools and the scripts. So just kindly go through this and then we'll jump to chapter 2. Yeah. Okay, so with this, I'll go back to RStudio. I've kind of summarized some aspect of this. Then I'll push all the files to the GitHub page, which I'm going to share as well. I would be sharing that. Okay, so we are looking at geographic data in R. So I will take you to my RStudio now. So I'll take this out, elapse this, do this. Mm. Okay, so sorry, so just I'll take this out. So okay. I wouldn't want to go back there. So for so please, okay, let me just pause. Okay, so for the chapter 2, we're talking about geographic data in R. So but before we start, from the book, you need to install some packages if you're familiar with R. So these are the packages that you need to install for you to be able to work along with me or use this file at all. So you have to install this, follow the steps just like I highlighted here. You don't have to download the entire GitHub folder for the book now. But if you need it for the exercises, you can download it, but it's going to take some time. So also this installation will take you some time as well. So first of all, take this on, remove the comments, install all these packages, the SF package, the Terra package, SP data large, install it as it is in the book. That's the same thing that the authors placed there, you can see. So when you get that installed, then you have to also install the entire book with the dependencies as well. So that's why this comment and this attribute is being added. So just take that and reinstall it. We are not installing from CRAN, so that's why we're using this. So for you to be able to use this, you have to install this package as well, remotes, if you don't have it already. So you can install that, then you'll be able to run this line of code. So I will share the GitHub repo with us because it's going to be there. Um, okay, I'll update it and then share later the link via email to all those who registered for it and those who registered on Meetup as well. So that is it. So that's the next thing. Install the book and the dependencies for all the packages and all the scripts. Everything is going to be prepared for you by running this code. That's just it. So the next thing is this. After you've gotten that done and you have your system ready, then you can load the packages. That means you are bringing those packages into your environment for you to be able to use the functions that belongs to those packages. So just do the same thing like this, then we'll be able to have everything ready. So now, our goal for today is we want to explain the fundamentals of geographic data models. So these basically two types. That's what globally what we will look at. We look at the vector and the raster data models. So I've tried to summarize the chapter, but if you're not getting everything here, you have to go back to the chapter 2. But I tried to kind of break it down, summarize it in something that is kind of simple to understand. So for the first one, I'll give time for questions. So just give it some time. Let me just go through a little bit, then I'll allow you to ask questions as well. So I'll try my best to answer your questions. So vector data data model in geographical data. In this, the context that we're looking at, we're not looking at the vectors that we're all familiar with. So it represents the world using points. So if we're talking about points, we're talking about kind of a vector. The reason why we're referring to vector is that it has to be two values. So we have to combine it together to give us that particular point. Okay. So we're using points, lines. So that will be combination of points. So lines and polygons as well. We'll explain all this in detail as we move on. So this vector data model, they are discrete. So they are well-defined, they have well-defined borders. So meaning that vector data sets usually have a high level of precision. So the precision is kind of in quotes, we're not saying 100% precise. So then it's also based on points located within a coordinate reference system. Okay? So when we're talking about a coordinate reference system, I try to get the definition here so that we don't get lost. So coordinate reference system defines with the help of coordinates. Oh, excuse me. Okay. So it shows how the two-dimensional projected map is related to the real locations on the Earth. So kind of the definition that I could bring up from QGIS. Oh, sorry, kind of rushing in from work. So so this is based on so then the points now, let's go deeper into it. So the points, they can be represented by self-standing features. Examples could be the location of a bus stop and a specific building, an address, maybe a street address or something. Or we can look at it as maybe a local government area. We can use a state. It could be a point. We are not looking at the entire space of that state. So we're looking at a specific point that kind of reference that state, not the entire size, like the shape, no. Okay, so those are the examples that I could bring up so that we don't get lost. Okay, so or they can be linked together to form more complex geometries, such as lines and polygons. So, and this is where we can say, okay, I might be looking at the state in a bigger picture. Maybe a street, the entire street could be a line. Polygons could be maybe a local government area or county. We can decide to use that. So don't get lost. Polygons might not represent the actual shape of a state or a county, but it could be something that we could create, kind of carve out, maybe when we're talking about something like raster. Just let's get this one there. I don't want to mix up the terms together. So most points geometries contain only two dimensions, can be the X point Y or the lat long. That's the example that I can give there. So it's much less prominent compared to three-dimensional geometries. We have those ones that are now includes the Z value. Okay, so that's basically that. So then the coordinate reference system, the definition there. So the next model is going to be the raster data model. Excuse me. Now close the door. Okay, so raster data model. So divides the surface of the earth up into cells of constant sizes. Okay, so that's why I don't want to mix it up with polygons. So this is representing actual shapes. It's constant. So then the basis is kind of the basis of background images used in web mapping. So you might have seen so many shape files and all this stuff. So those ones that belongs to the SF package or kind of characteristics that are different from raster. So don't get it mixed up, but we'll get to really go deep into raster before the end of this chapter. Okay, so they also have been a vital source of geographic data. So for those who are kind of founding professionals in the in GIS, they will be much more familiar with raster compared to vectors or something like that. So then, so it can be aggregates used to aggregate spatially specific features to a given resolution, meaning that they are consistent over space and scalable. So that's just some of the things that I read from the book. Okay. So now the introduction to simple features. So simple features is an open standard developed and endorsed by the Open Geospatial Consortium. It's a non-profit organization that actually is in charge of this. So simple features as SF, okay, is a hierarchical data model that represents a wide range of geometry types. From the book, we have 18 in numbers of these geometry types, but 7 are the most commonly used. So when we're talking about the 7, we're talking about points, line string, polygons, multi-point, multi-line string, multi-polygon, geometric collections. So those are the 7 that are commonly used for geographic research. Excuse me. Okay, so SF package provides classes for geographic vector data and a consistent command line interface for 2 important low-level libraries for geocomputation. So it's not working alone, that's the SF package. It's giving us access to all these packages that are highlighted here. You can see their uses are there and what they are meant for. It's actually kind of the SF package actually gives us ease in working with geospatial data. It's so easy. You'll get to see some features there. Like when you're talking about geospatial data, you're not looking at seeing geospatial data in form of a data frame. But that is something beautiful that the SF package gives to us. So it's easier for you to even work with geospatial data now using the SF package. So it's built on all these low-level libraries that are common before SF comes into the picture. Is kind of these are the ones that are there. So GDAL and all, you can read more about this. So I want to cover so much. Okay, so we have the GDAL for reading, writing, and manipulating a wide range of geographic data formats. So then PROJ, that's the powerful library for coordinate system transformation, geos, and so on and so forth. Just let's read up on that. So SF provides the same functionality and more previously provided in 3 packages. That's the SP, RGDAL, then the RGOs. These packages were actually created to give us interfaces to the GDAL, GEOS, and that's the SP. So for all this, you can get everything much more better, but it's the same functionalities that you get in SF. Okay, so simple features, SF, objects, in R are stored in data frame. And that is the beauty. That's what I love so much about it. And for those who created it, thank you. So in a data frame with geographic data occupying a special column, usually named geom or geometry. Geometry is mostly common from most of the data that I've worked with. You always see geography. So if you have all the packages installed and you've also installed the book, as I've stated before, you'll be able to have access to this data, that's the world data. So if you if we go back into our studio, you'll be able to, if you run this, you'll be able to see the class of that data object. So it's an SF object, okay? It's simple features object, and it's also a stable data frame kind of. So it's a table, and it's also having that class of data frame. So it's so easy for you to even do whatever data manipulation you want to do with ordinary data frame also with SF objects. Okay, so we can summarize, you can filter, you can select. The only thing is, okay, we'll talk about that. That sticky situation that you get into, that the geometrical aspect characteristics is not taken out. So then you can also check the names of the columns that are within that object. You can get that like this. So then the content of this data object is not complete without, that's the geom column, that's the geometry column. So this gives it the spatial power. So that's where the geom column comes in. So you can explore that, and it's going to give you all this information about that single column. Okay? So okay, let me move a little bit, then I'll give time for questions. So remember, this column is kind of a class, a list column, because of all these features that you can get from it. So the list column, that it contains all the coordinates of the country polygons. Okay, so the geometry columns are list columns of class SF. That's the simple feature column. So we'll get to know more about that. So you can check the class again, then you'll be able to see it. So then you can also plot any SF object using this function. The plot function, it's available in the base R environment, and it also comes with the SF package. So both are there. So it's kind of built on the base R. So don't get lost if you see this there, but you can also use the question mark or get help within the R Studio to learn more about the function. So you'll be able to see that, okay, it's available as a function, the base R, and it's also a function in the SF package. So if you use that function, you can plot the entire data set, and you'll be able to see the different images that is going to be brought out. So just like we said, being a data frame, being an object that has the class of a data frame, you can summarize it, you can filter, you can do whatever you can do with ordinary data frame. Okay? So do you have any question at this point before I move on? Any question? If you have questions, please just signify, put it in the chat, or let me know if you want to ask the question. Okay. Thank you. So I'll move on. So just like we've talked about this special thing about SF objects is that they have the geometry. Okay, that's something unique about them. Okay, but that sticky situation, even if you're filtering the data frame object like, you'll still get the geometry column there. So, but you have the choice of removing that kind of sticky situation, that behavior. You can take it out. It's not referenced in this chapter 2, but we'll get to deal with it in chapter 3. So, but I decided to bring it. So why wait for chapter 3? So it's going to be kind of hanging in my mind that, okay, how do I do that? How do I do that? So that's why I brought it in. So if you want to remove that, your spatial aspects from your data frame, you can use this function st_draw_geometry. So that column, that SFC column, that's a simple feature column, will be dropped. So you have a normal data frame. Okay. So so if you check the class, you have only the 3 without the SF property like we had earlier. So it's going to be different from this. So the SF class is going to be taken out while you have the table and the data frame property still there. Okay. So now like we mentioned earlier, for any data frame, you can subset. The same thing with SF objects, you can subset. So in this example, what we're looking at is that we want to take the first two rows, then the first three columns. So if you run this, you'll be able to see that in R Studio. Maybe let me just go there, back to R Studio and do some of these things. Let's go back to Studio. Okay. So this is, okay, you'll get the installation done. I don't want to go into that. So, so what I actually did earlier, you can check the class. We run this. Oh, sorry, I've not, it's a new session. I'll load this. Okay. Oh, okay. So if I run this, we'll be able to get the information we're looking for. So this is the properties or characteristics, then the names of the columns that we have there. You can view it. You have all the information about the SFC. That's the special in simple feature column. So okay, thank you so much. Thank you. Okay, sorry, I didn't know I was muted. Okay. Okay, please. So this is what we have on the slides. So this is it. So you can see the class and also the names of the columns. So then the SFC objects. So if you click on that, you'll be able to see the features that are there. That's why it's called the simple feature column. There are so many information embedded there. You can also see there is a multi-polygon data model. So that's just that. So geometry columns are list columns of class SFC, just simple feature column. Okay. Okay. So as a simple feature object, you can use this function plot. If you put the question mark, let me put it in my console. Okay, so my question mark plot. So if I run this, so if you look at my help tab here, you can see it's coming up in so many packages. So, but the one that is actually of concern to us is the plot function from for the SF object. So you can see it belongs to the SF package. So it has a lot of arguments that you can add to it, which we'll also explore later. Then you can explore these functions, then you'll be able to do so much with it. So it's about exploring and learning more. So that is the function. So with the SF object, we can plot it directly. So if I click on this, we'll be able to see the plot. So it creates all this for us. So that is what we'll have there. So, but we'll see other kind of SF objects that we'll explore later. So that's that. So you can also summarize it. Click on this, you'll get a summary of that column. You know, this is just one column. This is the sticky feature that we're talking about. It's just one column is not it's not an SFC object, but it's still having the geometry features or characteristics attached to it. Okay, that's the sticky situation that we're talking about. It's wonderful and it's sticky. Okay, so that is just it. So any column that you take in out of a data frame that has that spatial characteristics would always no, please. Okay, so that is just what you'll see. So don't be alarmed. It's just telling you that, okay, I'm part of the spatial system or data frame. That's just that. So that is that. So then also, okay, I've explained that, okay, you can drop it if you don't want it. So if I run this first, okay, so okay, let's look at my environment. So I've done that. I'm my console. So the class now, you can do it one by one. So you'll be able to see that, okay, no SF properties or characteristics attached to it. No, none. And you can also check the columns now. We only have 10 columns instead of 11. So that geom column has been taken out. So you can also subset just normally like we do with data frames. Okay, so but this is what you have. So the first two columns, then two rows, then the first three columns, but the sticky geom would always show up. Okay, so just get used to that. So now let's look at the building blocks for, okay, this is going to be a long talk. So I'll go back to my browser, look at the summary better. Okay, so we've looked at subsetting it. So then the building blocks of SF objects. So we have the spatial columns, which are often called geom or geometry. So an example is this. So then there are SF objects. That column is SF objects and are composed of one or more objects of class SFG. That's simple feature geometries. Just like we explored there, there's so many informations that you can see about that column. So many information. Okay. Okay. So now the next thing is why simple feature. So it's widely supported data model. So because the unique thing is this, you can always put what you have here. Like the explanation is this widely supported data model that underlies data structures in many GIS applications, including QGIS and post-GIS. So which ensures that your work is cross-transferable to other setups, e.g. importing from and exporting to spatial databases. So that is why we need the simple features. So why use the SF package? These are the reasons: fast reading and writing of data, enhanced plotting for performance. SF objects can be treated as data frames in most operations. So SF function names are relatively consistent and intuitive. All begin with ST and ends with the name of the function that you want to use. So SF functions can be combined with the pipe operator. Okay, so this is the native pipe for those. You can also use the actual migrator pipe, can use that with it. So, and works well with the tidyverse collection of R packages. Okay. So SF's that simple feature support for tidyverse you can see that with the difference between the read underscore SF function that is from the SF package and a function for importing geographic vector data and the function st underscore read, which returns attributes stored in a base R data frame. So R and read underscore SF silently returns data as a tidyverse table. Okay, so that is basically the difference. So if you read you can, if you install the books package, you'll be able to run this. So if we run it, you'll get this for the st_read. So you have all this gibberish, whatever the information there. But if you're using read_sf, you get that simplified object, which is just an SF and data frame. Having the features of SF and data frame. So that's basically a unique thing about the using the SF package. So that is for that. So you can still continue to do the basic plotting with the plots function, like what we have here. Okay, I think we're still on time. Okay, so then we can also plot a single column. The reason why we can do all this is because of that sticky column, that is geom column, that's SF column. So this gives every column that property of that spatial power. So you don't have to bother about bringing in the geom. It's already stuck to it. So and till code do us part or what, okay? They're there together for life, except you remove it, actually. So that's it. Um, okay, so what else are we looking at? So plots can be added to each other. So I can have multi-layer of plots on each other. So, but one thing is just create what you have first, what you want to plot. So now we are subsetting to be for only continents in the Asia continent. So then before we can go ahead to plot, you have to kind of combine all these countries because, okay, let's go back to let me show you in our studio. Excuse me. Okay, out of here. Okay, this is what we have. So what we need to do first is we subset, okay? Then we'll combine, kind of unite all these different countries together. So let's just look at what we have there first. Okay, I'll select this, then Control Enter. So this is what we have. We have 47 rows, okay? They are all within the Asia continent. So we want to combine them as a single object, okay? So that we would be able to kind of visualize as an entirety on top of another layer. So if you want to learn more, we can only achieve that using this function, st_union. It belongs to the SF package. So if you want to know more about that, you can just run this question mark. They'll pull it up. Okay. Okay, let me close this. Okay. So you can see it's combine or union feature geometries. So we are uniting or combining the geometries together. So they're going to be a single layer on top of the entire world population map. So what you're going to do is that you have to, is more or less like, okay, we don't want to use pipe, but we have to create it like this. These two must be run together. So if you, sorry. Okay, so this is the plot. This is not working. Sorry, let me just start my session again. I think I didn't do it. Okay, the layer is supposed to be there, but maybe I ran it there. So let me just restart my session. We just restart. Okay. Um, I think we should have this. We can go ahead. Okay. So let me see. Okay. We did some subsetting there. Okay. Let me just restart live coding. Um, Load the package here. Mm, Let me this one. I don't think okay, let's go. No. This is just okay. Okay, now I get it. Okay. So I want this layer to be here. So that's why we have to run the two together. So that is just that. So the reason why this is possible is because of this argument. Add is equal to true. So if you are going to combine two layers of plots using this function, just use that. So that's what we're trying to explain. Plots are added as layers to existing images by setting this argument within the plot function. So that is for that. So that's what I'm trying to do. If you use this like this separately, you're going to get some errors there. So okay, I jumped some aspects here within the chapter that is better we delay it for chapter 5. Kind of too many references there to chapter 5, so I decided to skip that. So, but you can kind of revise on your own. So that's why I took that out. So then map bounding box. So for the function, the plot function, you can also work with bounding box within it. So you can expand it using there's a feature and an argument within that function, excuse me, that would allow you to give a vector. Okay. So a numeric vector that will give you 4 values from where you want the bottom to be that's the end of kind of the bottom of your map, the left side, the position of the left, right side, then the top and bottom. So if you might use some geography, if you are creating a map, maybe in like leaflets, you might have some points, geographic points that you can kind of pass to a function. If you're using maybe map view as well, there's also one in leaflets that you can use to create the bounding box there. So we're still going to do that. So I'll bring in when I need to bring it in, or when somebody is trying to, you can do some explanation using that. So, but here for this function, you can add that argument. So we are looking at India now. So we're subsetting that, okay, the name should be for India. So if we run this, so excuse me. So if we look at what we have in India, the object now, so it's just a single line, okay? So we'll now want to create that map and we add it to an existing one. So we want to look at, okay, we plot India based on this expand BB. If you look at kind of the function there, let me go. We have that. Okay, let me go to, okay, question mark plots. Okay. So the explanation is there. So you can look at that and you'll be able to understand it. So this is it. Expand BB. So it's a numeric vector. So fractional values to expand the bounding box with. So in each direction, the left side, the right side, top and bottom. So that's what we're just doing there. Then the LWD argument is for the line width. So I've tried to explain that here. So then the ST underscore geometry is a function for you to get set and replace or rename geometry from an SF object. Okay? So that's what we're doing here. So if you click on this, run the entire code chunk, they will be able to see that, okay, the India is actually kind of drawn out of the entire map of the world. So that's what we got here. So any question at this point? If you have any question, just let me know. Okay, so okay, the ST geometry is actually a function that will allow you to create a geometry from kind of maybe a subset or something. You have, let's just go there so that I don't make things up in my head. So you get set, replace or rename geometry. So what we'll do in this instance, let me go to the example. I subset this, I brought it out. Okay, I want only India. So if you look at all the columns, they are available here. Okay. Also the DSF column, that's simple feature column is also there. Okay. But right now we've created a subset and we want it. If you take out only, let's try that. Plots. Okay, India. So can you see what I have here for India? But it's plotting for all these values. 1, 2, 3, 4. So let's go look at what we have. So I've told you that, okay, that sticky situation is always there. Okay. So, but if I convert it to a geometry, it's going to kind of compact. Instead of creating for all these columns, I'm not interested in this. I'm going to like what we did, what happened here. Let me for the entire look at this. For the entire world is creating for each of these columns because all of them are stuck to that SFC. That's simple feature column. So we have all these plots there. So, but if you have to convert it to using that function, we'll be able to just get a single map. Okay? I hope that answered the question. Can see the difference there. Oh, okay, thank you. So that is sorted out now. Okay, thank you. Okay. Where are we? Oh, that's too far. Okay, so I'm moving out of this. Okay, so we look at the geometry type. Okay. Too many text here. Let's go back to the browser. So we'll be able to see something different. Okay, I have to re-render that. Mm. Okay, let me check. Okay, I think we have it. Okay, please, can you confirm if you can see the browser now, my browser?
Fine.
Okay, thank you. So, I don't want to use the RStudio for all this text. So we're looking at geometry types now. So the geometry types that we're having seven, we've mentioned that earlier. We have the points, line string, polygon, multi-polygon, multi-points, and so on and so forth. That's seven. So they are all based on standard encoding for simple feature geometries. They are all on within this encoding system for the geometries. So we have the WKB. So that is based using hexadecimal strings. It's easy to read for the computer, but the other one is human readable. Okay, so this is also another difference that, okay, is for GIS and spatial databases using WKB to transfer and store geometric objects in databases, spatial databases. Okay, so but both formats are exchangeable, and we can present one and we will naturally choose the WKT. So that's just what we're used to here. So the next thing is the, okay, the basis. Okay, the first one, that the point, that's the basis for each geometry. So for all the seven geometry that we're going to be interacting with, the point geometry is the basis for all of them. So a point is simply a coordinate in 2D, 3D, or 4D space. So an example is this. Then we have the line string. It's just kind of a sequence of points. So with a straight line, like a street can be a line string. So so connecting the points. So it's a straight line connecting the points. So example is what we have here. So a polygon is a sequence of points. You can see all of them points, points, points. Okay? Sequence of points that form a closed, non-intersecting ring. Okay? So we have polygons that we'll see an example. We have holes inside, but they're non-intersecting. Non-intersecting. That should be noted. So it's closed. So closed means the close that we're referring to here. Closed means that the first and the last point of a polygon have the same coordinates. So if you refer back to the book, you'll be able to see that. So polygon without, we have those ones without holes. I'll show you that, although it wasn't mapped here, but I tried to bring in the mapped view package to show you what it's like, so I don't just see just numbers. Okay, so that is for polygons. So simple features standard also allows multiple geometries of a single type to exist within a single feature within multi-version of each geometry. So these are from the book. So we have the multi-point, multi-line string, and multi-polygon. Then the last one is geometry collection. So it's going to be a mix, a combination of geometries, including multi-points, line strings, polygons, and so on and so forth. So we have this example. So the SF class now. So it's contained two parts, the geometry part and the non-geographic attributes. So from what we've seen so far from the word, then spatial powered data frame, every other column is the attribute. But that column, geom or geometry, it has the spatial geometry aspects of that SF class. So, but you can read more on this. That's why I created the link there. You go back to the book and kind of look at the illustration. So the illustration here is this. We have a point in London. Okay. So that point, 2 points, no, a single point with two values, that's the X and Y points. So we're going to convert that to a simple feature geometry using this function, st_point. So because without that, it's just a simple vector. So this vector now, we're going to convert it to a point that is having a feature, a simple feature geometry, okay? So that's the SF geometry now, okay? So the next thing is this. We now have a point, but we need to add that column, that sticky column to it. So that's that is geometry. So let's go back to our studio and I'll show you that so that you see how the whole structure was formed. So I'm back in my studio. I believe you can see that. So this is it. The first thing is this. Let's create this, the point. So we have the point you can see in the environments created. So if I go to my console and let me clean that up a little bit. So LND. So if you say that, you can see that is exactly an example of what we're talking about. That's the foundation now. You can see that's an example of what we have here. Okay, so the next thing is this. We have a SF geometry, but we don't, okay, let's look at the class. That's the next thing. Class, LND. So you can see it doesn't have the SF feature and characteristics attached to it now. No, it doesn't have that because that column, that sticky column, that's geom column or geometry is not there yet. So for us to create that column, to add that to it, we need to add a coordinate reference system. Okay, that's CRS. We add it to it by using this function and we'll be able to get something, that geometric column. Okay, so I'll do that now. So let's look at the class of LMD. So you can see now it's telling us that, okay, this is an SFC, that's simple feature column that's based on a point. That's the foundation of all of them. And it's also having this value there, the attributes. So let's look at what is actually in it. So you can see we have all the information, the attributes that we need to say that, okay, this is an SF geometry, okay? So that is one point, one single point. So now we want to add other attributes to it. If you read in the book is actually asking, we want to create a geographical, a spatial representation of the location, that's London, then the temperature at that instance, and in that location. So wherever I am in London, I took that point, the geographical representation of that point. That's the points. Okay, that vector that represents where I am, and I want to add a certain feature or attributes. That's the weather for that time. I can add the time as well and the dates. So those ones are going to end with the location now. That's what we're looking. So the only thing we're going to see, there are two things. The attributes, that's the non-geographical information, then the geometry. So that is the SFC. Okay? So that is being created here now. So now for us to have that data frame with that spatial power, we'll create our data frame separately, that's for the attributes. Then we convert it to a spatial object using this function st_sf. So this is going to add the attribute, combine the attributes within that data frame, and also the geometry that we've created earlier here. okay? So that will now give us an SF object. So if we look at that, LND SF, so that is that. So we can see now we have one single row with 3 attributes and the geometry column, which is a point geometry. So any question? So you can examine the results and you'll be able to see just like what we have there. So do you have any question here? So summarily, simple features are simply data frames, that's square tables, but with spatial attributes stored in a list column called that geom or geometry, usually called geometry or geom, so okay. So that is data frames with a spatial extension. And that extension comes from the geometry or geom column. Okay? So, any question? Wow. Of it. So SFG class represents different simple feature geometry points. Sorry, can you still hear me? My internet is kind of fluctuating. Can you still hear me? Okay,
Yes, ma'am.
thank you. Okay, thanks. So simple feature geometries, so you can kind of, they are all this. These are all the geometries. So we have the functions, all these functions, they all start with ST, then you have whatever they want to do at the end of it. So these are the functions that you can use to create all the geometries, okay? So these are the examples given in the book, but they didn't create the map. So, but there's a way that I can show you that. So what you need to do is install, because if you create these points, okay, you're not going to see it on the map. It's not on the map. So, but I can plot that because it's now having that spatial power. So what you need to do with the exception of the packages that you're installing from the book, install this package, map view. So then load it. You can take any of these points, any of the points, just copy and just push it in. So I've taken one of them. I think I took the first one. Yeah. So if I load the library and I run that code chunk, you're going to have a map. So you can see it's just a single point, but it has 2 values there that is combined as a vector and has been transformed into a simple feature geometry. So it's just a single point, okay? Just one. So I can take any of this, just copy and push it into the function, that map view function here. So I run that again. So I'll get that point. So it's still the same point, okay? So the same thing for the multi-point, just use that function. All these can be kind of gibberish or something you can't feel it, but you can feel it more by pushing it into, after converting it to a SF object geometry, just push into that function, then you'll be able to see it. This is a multi-point now. Okay. Oh, okay. Yeah, I need to run this. So, okay. So now I can view this, you can see these multi-points now. 1, 2, 3, 4. So it's a combination of 4 points with two that's represented by vector H. So that's that. So let's have a look at the other ones too. So this, run that, convert it to a SF object, polygon, then you see that, okay? So that's, you can see it has to, the starting and the end of that polygon has to be the same thing. The points they have to connect. So you can feel it now, but you can't feel it when you're just looking at the numbers and the vectors like that. So that's that. And okay, let's look at polygons with hole. Okay, sorry, I didn't run that. So here. So this has a hole which is represented by a square. Okay. The same thing. So you can explore on this because we're supposed to round up by 6:30. We'll continue, but let's just look at all of them. So that is that. So then the list one, we can also kind of copy this and view it. And just copy. So we'll run this. Okay, so I can just remember it's that geometrical, that spatial, simple feature geometry that you're mapping, not just the points. Okay. So look at that. Put it there. Okay, so you can say this is a geometry collection. It's not a polygon. So it's collection here. So you can also have a polygon somewhere different, but this is just the example we're having here. So any question, we have to continue kind of exhausted here. But if you have question, contribution, let me have that now. So, you have any question? So we're going to look at raster in the next class, but in the next session, so we don't want to exhaust most of the time here. It's late here. If you have questions, let me know. Oh, let me go back. Okay, so we're going to share the project folder, the repository. We're going to send it by email, so you'll get to see all the summarized information there. So these are all the polygons that we've created, and you can play around with it. So that's just it. So let's go back to the book. Maybe I can still look at some things there. So I'll be able to. So you can, for all the images that you're seeing there, the function, how to create them was not shown there. So that's what I did with the map view. So you can try and see, just put all of them, you'll be able to get the same thing. Just convert to SFG, that's simple feature geometry. Then you'll be able to use this. Look at the slide, the Quarto document, then you can replicate that. So the SF class is explained here. It goes through, then where did I stop? So see. Okay. So, okay. So actually, simple feature columns, we've talked about it. That's the geometric column. So it's basically the same thing that we're talking about. It's just going deep into it. If you create it, that's ST_SFC for the 2 points, you have all this information about it. Okay? So you also have that the bounding box is created for you. So it's based on the values that you have in the vectors that were used to create those points. So you have the minimum X points, the minimum Y points, the max, and so on and so forth. So then that's basically, so you can use that for the polygons, just a repetition of the same thing. So that's basically, it's not, sorry, I wouldn't say it's not difficult, but it's something that you can just play around with because something you can see. It's visual, you can create the maps and you can feel what you're working with. So that is what we have here. So just play around with this, copy the same thing, use the map view to see what you've created. That's SF. Sorry, excuse me there. So we'll continue in this next class. We wouldn't do much of introduction then. We are all familiar with it. Then we'll be able to continue. So if there's any question, comments, you want to volunteer for the next class, we'll be willing to allow you to do that. We're here to support, but we just want everybody to read, learn, and share your knowledge back with the community. We're going to have the video for this class pushed to our YouTube page. So do we have? So we'll say thank you. So next month, we're going to be sharing the time for the next session. We'll have a date. It's always the last 2 weeks in the month. That's what we plan to do. So we'll give you time to review all what we've learned, watch the videos. If you have any question, you can send email or our WhatsApp group if you want to join that. So those are the platforms that we can use to communicate after this session. So we have another session that's coming up on Saturday. So Saturday is going to be for our Python Shiny. So for those who want to create data products like dashboards, then you can join that study group as well. So let's learn together this year. Let's learn together mostly. That's what we want to achieve. We want to kind of catch up with everybody.
Thank you, ma'am.
Okay. Okay, it has. Oh boy. So I'll stop the recording now. Thank you very